Um, Welcome to today's deep dive. We have an incredibly dense, highly technical stack of source material to get through today.
We really do.
Yeah, and I want to set the parameters right up front. The insights we are unpacking come directly from a post by Rooted Layers.
Right. AI insights grounded on research.
Exactly. And specifically, we are tearing into Chapter 14 of their blueprint today.
Which is entirely focused on multi-agent design.
Right. And if you are listening to this right now, you are likely embedded in the tech space.
Or at least heavily invested in understanding where AI is actually heading.
Yeah, especially when we start talking about structuring really complex work. You are also undoubtedly seeing a massive influx of noise.
Oh, the hype is everywhere.
It is. Hype and, frankly, wild marketing claims about what happens when you string up a bunch of AI agents together. So the mission of this deep dive is to cut completely through that noise.
That is the perfect framing.
We are going to treat this time like two researchers thinking out loud, curious, calm, analytical, and driven entirely by the data.
And that's so necessary because the core conflict we have to address immediately, the exact reason this post from Rooted Layers is so important, is that the tech industry at large is answering a profoundly important architectural question with way, way too much casualness.
And that question is simply, when should one AI agent become several?
Exactly. The prevailing assumption right now, fueled heavily by social media demos and vendor hype, is that you should add more agents whenever you want a system to have, quote-unquote, more intelligence.
Right. There's this pervasive belief that if you throw 5, 10, 20 language models into a virtual room,
give them different job titles.
Yeah, and just let them talk to each other, a vastly superior emergent solution will just naturally materialize.
But the post argues forcefully that this is an entirely flawed mental model.
Okay, let's unpack this. Because I have to admit, the idea of magic emergence is incredibly seductive.
It really is.
If I am building an application and I have access to these incredibly powerful API endpoints, my instinct is to simulate a human brain, or maybe a human company.
The logic seems sound on the surface, right?
Right. Humans collaborate to solve hard problems, so multiple AIs should collaborate to solve hard problems.
But the true north of this post, its absolute central thesis, is that multi-agent design is not about magic emergence.
No.
It is fundamentally about workflow decomposition.
Workflow decomposition.
Yes. It is a highly practical, almost ruthlessly conservative engineering tool. You only deploy multiple agents when role separation, structured handoffs, or independent review will clearly and measurably improve the workflow.
So it's not just throwing agents at a wall to see what sticks.
Not at all. A useful way to think about this is to completely strip away all that anthropomorphic language we use around AI.
Okay.
And view multi-agent design strictly through the lens of traditional systems engineering. We are talking about separating rigorous workflow architecture from what the post brilliantly diagnoses as agent theater.
Agent theater. I love that term.
It's a trap, and it is catching a lot of very smart development teams right now.
So break down agent theater for us.
Agent theater is when you manufacture the illusion of complexity. You instantiate 3 different language models in your code. You name one the researcher, you name one the writer, and you name one the editor.
Right.
You give them slightly different system prompts, but under the hood, they're all pulling from the exact same foundational model.
Same context windows.
Exactly. They have the exact same context windows, they're using the exact same tools, and they share the exact same access permissions.
But it looks incredibly sophisticated on a terminal dashboard, right? Seeing them chatting back and forth.
It looks amazing for a demo, but functionally, they aren't doing distinctly different jobs. It's a simulation of work.
Not an optimization of work.
Exactly.
I see exactly what you mean. It's like giving one person 3 different hats and pretending they're an entire construction crew.
Yes.
Putting a CEO hat on a language model and a developer hat on the exact same model doesn't magically multiply its IQ or its capabilities.
No, it just makes it hallucinate a corporate org chart while burning through your API budget.
Which is painful.
It is. And this fits a broader pattern we're seeing across the industry. We constantly mistake added complexity for added capability.
We assume that because a system has more moving parts, it must be robust.
Or more nodes in a network topology, more agents chatting in a loop. But basic workflow design teaches us the exact opposite.
Right, because every handoff between 2 agents is a potential point of failure.
Every single time. Every time Agent A has to compress its internal state and explain its output via natural language to Agent B, you lose fidelity.
You introduce latency.
You compound token costs. It's a massive drag on the system.
Which brings us to the operational foundation of this whole concept. The post outlines the 4 pillars of practical multi-agent design.
These are crucial.
They are 4 highly specific workflow design questions that Rooted Layers insists must be answered before you even open your code editor.
Before you write a single line of code.
Right. And what strikes me about these 4 questions is how thoroughly they avoid the philosophical debates, about AGI or consciousness.
They are purely, relentlessly operational.
Exactly. So, number 1, is one agent enough? Number 2, if not, what roles should actually be split? Number 3, how should those roles exchange work? And number 4, where does human supervision remain mandatory?
Let's really scrutinize that first question. Is one agent enough? Because it represents a massive paradigm shift from how developers are currently incentivized to operate.
The psychology of why teams rush past this is fascinating.
It is, because in today's landscape, building a robust single-agent system feels almost, too simple.
It doesn't look like a breakthrough.
Right. A developer might look at a complex task, say, analyzing a massive financial report and drafting a summary, and think, why build one prompt to do this when I can build a multi-agent swarm to debate the financials?
Sounds much cooler for the resume.
Exactly. But if that single agent has a large enough context window, access to the right data retrieval tools, and a clearly structured prompt, it can own the task entirely.
Yeah.
The post demands that if a single agent can hold the context and execute the tools, you must keep it as one agent.
Okay, let me play devil's advocate here for a second.
Go for it.
Because if I'm a developer, I'm looking at the token limits of these models. Even with 128K or a 1 million token context window, models get quote-unquote lazy.
They do. They lose track of instructions in the middle of massive prompts.
Right. So doesn't splitting the task into a reader agent and a writer agent guarantee a higher quality output? Because you are clearing the context window and letting the model focus on one hyper-specific thing.
It's a very common assumption. But it ignores the coordination task.
The coordination task.
Yes.
Yeah.
Think about it. You clear the context window for the writer agent, sure, but how does the reader agent pass the information to the writer?
It has to summarize it.
Exactly. And in that summarization, nuance is lost. The writer agent now has a highly focused context window, but it contains secondhand compressed information.
You haven't actually solved the complexity problem.
No, you've just shifted it into the communication layer between the agents. And as you mentioned, you are now paying API costs for the reader to generate the summary and paying again for the writer to process it.
So unless the task is so massive that it physically exceeds the token limits of a single call.
Or requires fundamentally different tool access.
Right. Splitting it often degrades the output quality while increasing the cost.
Exactly. It's a net loss.
That concept of the coordination tax perfectly bridges into the second pillar. If one agent isn't enough, what roles should actually be split?
The research here is uncompromising. You don't split roles based on human job title.
Or because it makes for a neat demo.
You split roles when the subtasks genuinely require different tools, different system permissions, or entirely different evaluation logic.
Ground this for us. Let's make this real for the listener.
Okay, think about the principle of least privilege in cybersecurity.
Yeah.
If you have an enterprise workflow where an AI needs to query a highly secure internal SQL database containing customer financial records.
Very sensitive stuff.
Yes. And then format some of that data into a public-facing email marketing campaign. That is a legitimate, necessary role split.
Because the agent drafting the marketing email should absolutely not have the system permissions to execute arbitrary SQL queries on your secure database.
Exactly. That would be a security nightmare. Therefore, you create a data retrieval specialist agent with bounded, secure tool access.
And a communications specialist agent with no database access whatsoever.
Right. That is genuine role separation driven by system architecture.
Not agent theater.
Not agent theater.
That makes total sense. It's not about simulating two people talking. It's about isolating distinct software functions.
Which naturally brings us to the third pillar.
How should those roles exchange work?
This is where the post draws a very hard line in the sand regarding system architecture. Are these agents just chatting in an endless free-form text loop?
Or are they handing off highly structured artifacts?
The blueprint heavily favors structured handoffs, but we'll get into the mechanics of that shortly.
Yes, we will definitely tear into that. But let's hit the final pillar first. Number 4. Where does human supervision remain mandatory?
This fourth pillar anchors the entire multi-agent philosophy in reality. There is this tendency to want to automate a process end to end.
Remove the human entirely to maximize speed.
Exactly. But Rooted Layers points out that there are policy judgments, final approvals, and complex interpretive decisions that simply cannot be safely or legally delegated to an automated system.
Regardless of how many review agents you stack on top of each other.
The human is not an external observer of the multi-agent system. The human must be engineered into the workflow as a mandatory routing node for specific, high-stakes decisions.
So to really understand how to answer these 4 questions in practice, the post pivots into a phenomenal deconstruction of the core academic literature.
But it doesn't treat these papers as abstract theoretical reading.
No, it frames them as specific, deployable architectural tools. So let's dissect these, beginning with the first major paper highlighted, MetaGPT.
MetaGPT. The paper focuses on metaprogramming for a multi-agent collaborative framework.
Which sounds incredibly dense, but it's actually super practical.
It is. MetaGPT is critical because it represents one of the clearest examples of a role-based pipeline. Its architectural value, and the reason Rooted Layers highlights it, comes from a very specific design choice.
And that choice is that the agents in MetaGPT do not just chat with each other.
Right. They exchange structured artifacts and documents. They follow standard operating procedures.
SOPs, just like a human corporate entity would.
Exactly.
And here's where the comparison to human collaboration gets incredibly practical. When real, complex work gets done in a professional engineering setting, we obviously chat in Slack or Teams.
Sure.
But the actual work doesn't progress based on a chat log. We exchange artifacts.
A software architect doesn't just verbally describe a system to a developer over coffee.
Right. They write a product requirements document, a PRD, or an API specification.
And the developer doesn't just say, hey, I fixed the code. They submit a pull request.
MetaGPT forces AI agents to operate exactly this way. The architect agent must output a formally structured design document before the developer agent is allowed to begin generating code.
And that structured deliverable is the key. A useful way to think about this is that you should use the MetaGPT architecture when your system naturally decomposes into specialist roles that require these kinds of rigid, document-driven handoffs.
It eliminates the terrifying ambiguity of natural language chatter.
Completely. If Agent A is tasked with data extraction and its required output artifact is a heavily structured JSON file.
JavaScript object notation, which is just a standard text format for storing data.
Right, thank you. If it outputs a structured JSON file, the workflow becomes highly legible. The system doesn't have to guess what Agent A meant.
You, the developer, can look at the JSON file and instantly run validation checks on it.
If it fails, the pipeline halts. If it passes, Agent B takes the JSON file and begins its work.
So let's contrast that strict, document-driven approach with the second paper the post highlights, ChatDev.
ChatDev is fascinating.
The premise of ChatDev is communicative agents for software development. Now, this is another strong role-based collaboration system, but instead of focusing purely on the artifacts, it uses staged software team roles as the organizing frame.
So you literally have an agent acting as the CEO. One is the CTO, one is the programmer, one is the tester.
Moving through a waterfall process.
Right. And the reason ChatDev matters from an architectural standpoint is that it gives you a pipeline view of multi-agent collaboration rather than a pure dialogue view.
Even though the agents are using a chat interface.
Yes, their interaction is heavily staged and sequenced based on traditional software development life cycles. Think of it not just as a simulated company, but as an automated CI/CD pipeline.
Continuous integration and continuous deployment.
Exactly. The CEO agent isn't a literal boss making arbitrary decisions. It operates as the initial requirements gathering node.
The work only flows down to the developer node once those requirements hit a strict programmatic threshold.
So you deploy a ChatDev-style architecture when you want that rigid, staged, unidirectional flow of work?
Okay, so MetaGPT gives us artifact handoffs, and ChatDev gives us staged, unidirectional pipelines.
Correct.
Now let's look at the third paper, which is arguably the most famous and widely deployed right now, Autogen.
Autogen completely changed the landscape.
The paper is titled Enabling Next-Gen LLM Applications via Multi-Agent Conversation. It made multi-agent conversation programmable, customizable, and reusable.
It uses conversation itself as the primary coordination fabric.
Which is a massive architectural divergence from the first two.
It is. Autogen is incredibly flexible. You can set up almost any topology of agents. You can have them talk in a round-robin style, you can have hierarchical chats, you can have them group chat.
But rooted layers includes a very severe warning here.
They do. Autogen's practical value is its extreme flexibility, but that exact flexibility makes it incredibly dangerous and easy to overbuild.
Let's dig into why that is dangerous, because if I'm a developer, flexibility sounds great.
Right, it sounds ideal.
But the post explicitly flags that treating conversation as your default coordination fabric is a trap if you don't constrain it with ironclad stop conditions.
It is a massive trap.
If you spin up 3 Autogen agents, give them a complex problem, and say, discuss this until you find a solution, what actually happens in practice?
What happens in practice is often a catastrophic waste of compute.
Catastrophic.
Yes. Language models are fundamentally designed to predict the next plausible token in a sequence. They are also fine-tuned to be helpful and agreeable.
Oh, right. So they just want to agree with each other.
Exactly. If you don't build in strict programmatic stop conditions, 3 Autogen agents might get stuck in an endless loop of polite agreement.
Agent A proposes a mediocre solution.
Agent B says, that is a fantastic solution, we should also consider X.
Agent C says, I agree with both of you, X is a great addition.
And they will just keep complimenting each other and summarizing each other's points until they burn through your entire API token limit.
That is hilarious and terrifying.
Or alternatively, they might hallucinate entirely new constraints that weren't in the original prompt just to keep the conversation going. The conversational fabric is powerful for brainstorming, but it's slippery and unbounded.
It is not a rigid artifact handoff.
But not at all.
That's a brilliant breakdown. So if we synthesize these first 3 papers, we see 3 completely different mental models of how work gets done.
3 entirely different paradigms.
Autogen is like putting a bunch of highly articulate, highly agreeable consultants in a conference room without an agenda and hoping they talk their way to a solution.
Yes.
ChatDev is like a traditional waterfall assembly line where work passes from one specialized station to the next.
Right.
And MetaGPT is a strict corporate compliance environment where work absolutely cannot move forward until a formally structured document is submitted, reviewed, and approved.
It illustrates perfectly why you cannot just pick a multi-agent framework at random. You have to match the architecture to the actual shape of the task.
Right. If your task requires rigid reliability, you don't want the consultants in the conference room.
No, you do not. Which brings us to the 4th paper, MD.
MAD, which stands for Multi-Agent Debate.
The post specifies that MAD should be treated as a reliability paper, not a general architecture paper. It is designed for situations where multiple agents are deliberately prompted to disagree productively.
So MAD is not about role decomposition. You aren't splitting a task into researcher and writer.
No. You are giving the exact same complex task to multiple agents, and you are explicitly instructing them to debate the answer.
The goal is to achieve better answer quality through adversarial comparison. But if I just want a better answer, why wouldn't I just take a single model and prompt it to think step by step and review your own work?
A lot of people ask that. Why pay to have 2 models fight about it?
Exactly.
Because a single model reviewing its own context window often suffers from confirmation bias. Once an LLM outputs a line of reasoning, the subsequent tokens are statistically biased to support that initial reasoning, even if it's flawed.
It anchors on its own previous output.
Exactly. So, by instantiating a second, entirely separate agent whose explicit system prompt is to act as a harsh critic or an adversarial debater, you force the generation of alternative reasoning paths.
The tit-for-tat token generation between the 2 agents surfaces logical flaws that a single pass would easily miss.
You deploy MAD when you need to surface these flaws in highly complex reasoning tasks. But you have to accept that you are multiplying your token costs by the number of debate rounds.
And that leads to the 5th and final paper, Reconcile.
Yes, Reconcile takes the debate concept from MAD and matures it significantly.
The paper focuses on improving reasoning via consensus among diverse LLMs. The post points out that Reconcile matters because it pushes multi-agent debate into a structured, confidence-aware decision process.
It explicitly manages consensus and disagreement rather than just letting them argue indefinitely.
Right, so the agents shouldn't just debate. They should weight their arguments based on confidence scores and systematically work toward a consensus.
Exactly. If we pull back and look at all 5 of these papers collectively, Rooted layers extracts one overarching architectural insight that is arguably the most important takeaway of the entire post.
And what is that?
Multi-agent systems exist to solve three fundamentally different problems. First, role separation. Second, reliability through critique. And third, task decomposition through artifact handoffs.
This is a crucial distinction. These three problems should never be confused.
Never.
If you build a planner reviewer pair, which solves for reliability through critique, that is a totally different architecture than building a role-based software pipeline, which solves for task decomposition.
Mixing these up is how systems fail in production.
Precisely. If your goal is to get a highly reliable factual answer to a complex legal question, you might want a critic overlay or a debate system. You want adversarial review.
Right.
But if your goal is to build a complex software application, having two agents debate the philosophy of Python syntax won't write the code.
It won't write a single line. You need a role-based pipeline with strict deliverables.
If you try to use Autogen's free-form conversational fabric to build a complex software pipeline without strict stop conditions and typed artifact handoffs,
Your agents are going to spend all their compute cycles chatting about the code instead of actually compiling it.
it all comes down to absolute intentionality.
It really does.
Now, the post does briefly mention some protocol layer infrastructure, things like MCP.
The Model Context Protocol.
Right, which is emerging as a standard way for AI models to securely access external data sources, and A2A, or agent-to-agent communication protocols.
But it notes that the literature in this specific chapter is much stronger on high-level workflow patterns than on mature, standardized inter-agent protocol design.
So the focus remains strictly on the workflow.
Exactly.
And that brings us to section 3 of our discussion, the escalation path, or how to actually choose the right architecture.
This is where it gets very hands-on.
The post provides this brilliant method comparison matrix and an if-then decision tree. The core philosophy here is that multi-agent design must be viewed as an escalation path.
Never as a baseline. That phrase, escalation path, is the antidote to agent theater.
You do not start at the top.
You do not. The post outlines 5 distinct levels of escalation. Let's start with level 1.
Level 1 is the single orchestrator.
The rule is absolute. If one agent can still own the task with bounded tools, keep it as one agent. It is the cheapest, clearest, fastest baseline you can build.
The main risk at level 1 is overloaded responsibilities.
Giving one single agent access to 20 different API tools or a system prompt that is so long and complex that the model loses focus and begins hallucinating tool calls.
But the discipline comes in how you react to that risk. You only escalate from level 1 to level 2 when that specific risk of overloaded responsibilities becomes the primary bottleneck of your system.
Exactly. You don't escalate just to escalate.
So level 2 is orchestrator plus specialists. You escalate to this level only when distinct roles genuinely need different tools or different system permissions.
The strength of level 2 is bounded delegation with clear control. The orchestrator acts like a routing manager, analyzing the user intent and handing off very specific subtasks to tightly scoped specialists.
However, the post issues a massive warning about the primary risk at level 2.
Fake specialists.
Fake specialists. We touched on this earlier, but it is the most common failure mode in multi-agent design today.
If you escalate to an orchestrator and 3 specialists, but the specialists are all just running GPT-4, they all have the same basic web search tools, and the only difference is that one has a system prompt saying, "You are a witty writer," and the other says, "You are a stern editor."
You have not actually separated the roles functionally.
No, you are just paying for extra API hops. A true specialist, as defined by the matrix, has a distinct tool set, restricted permissions, a specifically defined output schema, or a unique evaluation logic.
It might even be a completely different, smaller, fine-tuned model.
Exactly.
Let's map this out with a concrete, continuous example for you listening so you can see how this escalation actually works in practice.
Okay, let's hear it.
Imagine you are building an automated customer service workflow for an e-commerce platform. The level 1 single orchestrator receives a customer email complaining about a late package.
Pretty standard.
The orchestrator has access to a check tracking tool. It looks up the tracking, sees the delay, and drafts a polite apology email.
Perfect. Keep it level 1. It's fast and cheap.
But what if the customer demands a refund? Processing a refund requires write access to a highly secure payment gateway, and updating the customer's lifetime value metric requires access to a separate, secure analytics database.
The level 1 orchestrator should absolutely not have global write access to your payment gateway. That's a catastrophic security vulnerability.
Exactly. So you hit the bottleneck. You must escalate to level 2. The orchestrator analyzes the intent, realizes it's a refund, and delegates that specific subtask to a secure financial specialist agent.
This agent is isolated. It only has the payment and gateway tool, and it can only execute refunds up to $50.
That is genuine, security-driven role separation.
That is a perfect illustration. If we connect this to the bigger picture, you only ever move up a level when the weaknesses of the current level fundamentally hold the workflow back.
So when do you escalate from level 2 to level 3? The role-based pipeline.
The blueprint states you escalate to level 3 when the handoffs become artifact-heavy and sequential.
If the work naturally moves through staged artifacts like drafting a massive legal brief or full-stack software engineering, a simple orchestrator to specialist hub-and-spoke model isn't enough.
No, you need a rigid pipeline. The strength of level 3 is strong artifact flow and reviewability. You can inspect the document at every single stage of the assembly line.
But the inherent risk of level 3 is rigidity.
It is very rigid.
If the tasks flowing into your system vary wildly from day to day, a strict staged pipeline will shatter. It's like trying to run a bespoke, custom artistry project through a robotic car manufacturing assembly line.
The pipeline expects a specific input to produce a specific output. If the input is ambiguous, the pipeline halts.
Now, what if the tasks are consistent, the pipeline is working, but the final output quality just isn't reliable enough?
That is when you escalate to level 4, the critic or reviewer overlay.
You deploy level 4 specifically for high-value outputs where you need targeted reliability improvement. You literally inject an agent into the workflow whose sole purpose is to ruthlessly review the primary agent's work against a set of constraints.
But the risk here is purely economic and latency-based. You are adding extra cost and doubling the response time for very little gain if the task is easy.
You wouldn't use a critic overlay to verify the weather forecast.
No, but you absolutely would use it to review the SQL query generated by an agent before it is executed against your production database.
And finally, you only escalate to level 5, the debate or consensus group, when a simple critic review is no longer sufficient.
You reserve level 5 for incredibly hard, ambiguous judgment tasks where disagreement itself is informative.
These are tasks where there isn't necessarily a single objective correct answer, but rather a need to explore trade-offs and edge cases.
And the post warns heavily that this level is computationally expensive and incredibly easy to overuse.
The entire matrix is an exercise in the discipline of constraint.
It really is. It forces you, as the system architect, to mathematically and operationally justify every single additional agent you introduce into the topology.
If you start at level 5, if you build a massive 5-agent debate system to handle simple customer service queries that a single level 1 orchestrator could handle, you are burning compute.
You are wasting your company's money, you are introducing massive latency, and you are dramatically increasing the surface area for unpredictable errors.
That discipline of constraint provides the perfect transition into section 4 of our outline.
The default multi-agent blueprint and best practices.
Yes. Rooted Layers lays out a highly practical, surprisingly conservative build order for anyone engineering these systems. Let's walk through these 5 steps meticulously, because if you are building AI workflows today, this is essentially your survival roadmap.
Step 1. Build a single-agent baseline first.
We truly cannot overstate the importance of that first step.
If you do not build the single-agent baseline and measure its performance, you have absolutely no scientific way to know if your complex multi-agent system is actually an improvement or just an expensive illusion.
You must push a single agent to its absolute breaking point. You need to know exactly why it is failing. Is it hallucinating? Is it dropping tool calls? Is it running out of context?
Which leads directly to step 2. Identify failures that are actually role separable.
When your single agent inevitably fails on a complex task, analyze the failure. Is it failing because it's trying to juggle too many conflicting tools at once? Is its context window too cluttered with irrelevant data?
If so, the failure is role separable.
Step 3. Split only the roles needing different tools, permissions, or deliverables. We've hammered on this, but it is the ultimate antidote to agent theater. Do not split roles for aesthetic reasons.
And then we reach step 4, which is arguably the strongest architectural mandate in the entire blueprint.
Add type handoff contracts.
The rule is explicit. Prefer artifact handoffs over freeform chat. What's fascinating here is how deeply this ties into traditional software engineering best practices, specifically microservices architecture.
Right. When agents exchange typed outputs like a specific JSON schema, a strictly formatted markdown table, or a programmatic code patch, The coordination between the agents becomes completely legible, predictable, and debuggable.
Legibility is everything.
Let's really visualize why this matters for the listener. Imagine you have two agents communicating via a free-form Autogen chat. Agent A says, I researched the competitor, and I think we should highlight our pricing.
Agent B replies, good idea, I'll draft the copy, but let's tweak the tone to be more aggressive.
That conversation, while impressive to read, is structurally invisible to your system architecture. The system doesn't know what data was actually passed.
It's a black box.
But if Agent A is constrained to output a formally structured proposal schema in JSON with explicit fields for competitor name, proposed strategy, and confidence score, and Agent B is constrained to read the JSON and output a revision schema,
You, the developer, have total control.
you can intercept those JSON objects. You can write traditional code to validate that the confidence score is above 80% before allowing Agent B to proceed.
The system is no longer a black box of AI chatter. It is a visible, deterministic pipeline of work.
That visibility is the only way you can maintain control over a system in production. And speaking of control, the blueprint includes a vital rule regarding human-agent collaboration.
The post insists that human review must appear as a first-class role in workflows where approval, interpretation, or policy judgment cannot be safely delegated.
So what does this all mean for you, the listener? Whether you are a developer writing the code, a product manager designing the workflow, or just an executive trying to navigate this massive shift in how work is accomplished.
The prevailing narrative has often been that AI will simply operate autonomously in the background, rendering humans obsolete.
This blueprint says the exact opposite. You are not being replaced by a swarm of chatting AI agents. You are being structurally integrated as a critical, irreplaceable routing node in the workflow. The architecture explicitly requires your policy judgment.
It formally elevates the human's position in the loop. You aren't just a passive observer watching a dashboard. You are the final, highest clearance agent in the pipeline for high-stakes decisions.
This conservative build strategy, starting with one agent, isolating the failures, adding only genuine specialists, enforcing rigid artifact handoffs, and integrating humans for final policy judgments, is the gold standard for enterprise AI.
It really is.
But this raises a critical issue. If we know this conservative blueprint is the gold standard, why are so many development teams crashing and burning when they launch these systems into production? What is going wrong?
That brings us to Section 5, Failure Modes, Anti-Patterns, and True Evaluation.
Rooted Layers outlines very specific pitfalls that teams fall into. The first anti-pattern is starting with large agent teams. We've covered extensively why that's disastrous. It skips the necessary baseline metrics and fully embraces agent theater.
But the second anti-pattern is particularly interesting, letting conversation substitute for interface design.
This is a profound insight into how developers are currently misusing LLMs.
Let's think about traditional software development. You would never build a complex enterprise application without designing a structured user interface. Drop-down menus, radio buttons, specific text input fields with character limits. You guide the user's input.
But with AI, developers often get lazy.
They do. They just throw two agents into a blank text box, give them a vague prompt, and hope the language models will figure out the interface and the data structures themselves through conversation.
The post argues that conversation is a terrible, highly error-prone substitute for rigid interface design between agents. The typed artifacts, the JSON schemas, the markdown templates are the interface.
If you don't design the interface, the agents will hallucinate one, and it will break.
The third anti-pattern is giving all agents the exact same system permissions. As we discussed, that completely destroys the concept of role separation and creates massive, unnecessary security vulnerabilities across your entire system.
The fourth anti-pattern is using debate where simple verification is cheaper.
If you just need to know if a block of generated Python code will compile, you do not need two LLMs debating the elegance of the syntax for 5 rounds. You just need a single agent with a tool that runs a compiler and returns the error codes.
Exactly. And the fifth anti-pattern is adding specialist roles without specialist metrics.
Which raises an important question for anyone investing time or capital into building these systems. How do you actually evaluate them?
The post provides strict, unforgiving criteria. You cannot just measure how smart or human-like the agents seem in their internal chat logs.
You must judge the system entirely by end-task quality. Did the multi-agent system actually solve the user's problem better, faster, or more accurately than the level 1 single-agent baseline?
And it's not just about the final answer. You also have to measure coordination overhead. How much extra compute, how much time, and how many millions of tokens did you burn just having the agents plan the work and talk to each other before they actually did the work?
You have to measure latency and cost per handoff. Every single time an artifact moves from agent A to agent B, it costs your business time and money.
But the absolute most critical evaluation metric highlighted in the post is failure localization.
Failure localization. This simply means when the final output is wrong, and it will be wrong eventually, how easy is it to find the specific broken node in your system?
If you violate the blueprint, if you build a system with 10 conversational agents talking over each other in an unstructured, free-form Autogen loop, and the final answer presented to the user is a massive hallucination, how do you debug that?
You can't. It's a tangled, impossible web. You would have to manually read through thousands of lines of inter-agent chat logs trying to figure out which agent introduced the bad assumption.
Which agent failed to catch it?
And which agents just politely agreed with it to keep the conversation moving. It's an absolute nightmare for a developer. It makes the system unmaintainable.
But if you follow the post's advice, if you built a level 3 role-based pipeline with typed artifact handoffs, failure localization is trivial.
Exactly. The debugging process becomes totally deterministic. You check the artifact produced by the data extraction agent. Is the JSON correct? Yes. Okay. You move to the next node.
You check the artifact produced by the drafting agent. Is it correct? No, it hallucinated a statistic that wasn't in the extraction JSON.
Boom. You have instantly localized the failure to the drafting agent. You can now tweak its system prompt, restrict its tools, or swap it for a more capable model without touching or breaking any other part of the workflow.
That is the ultimate power of workflow decomposition.
Rooted Layers states this bluntly, and it should be the golden rule for every AI developer. If your complex multi-agent topology does not clearly beat a strong, tool-bounded single-agent workflow across these specific metrics and task quality, coordination overhead, latency, cost, and failure localization, then it is complexity without justification.
It is just an expensive science experiment, not a production-ready enterprise system.
It demands rigorous, almost painful honesty from engineering teams. You have to be willing to look at the incredibly complex, beautifully intricate multi-agent architecture you just spent a month building and admit, my simple single-agent baseline actually completed this task faster, cheaper, and with fewer errors. I need to tear this down and roll it back.
That is a profoundly hard thing to do when the entire tech industry is screaming that more agents equal more intelligence.
But that's exactly why we do these deep dives, to find the grounded, data-driven research that tells you how these systems actually behave under pressure, rather than how the vendor marketing brochures say they work. So as we synthesize this massive amount of information from the Rooted Layers blueprint, let's crystallize the core takeaway. Multi-agent design is not about creating a messy, chatty, artificial brain.
It is fundamentally about conservative, deliberate workflow decomposition. It is about building a clean, highly observable, artifact-driven pipeline.
The mantra provided by the post is brilliant in its operational simplicity. Start with one agent first, escalate to specialist second, enforce structured handoffs over free-form chatter, and utilize debate only when reliability strictly demands it.
It strips away the magic and anchors the entire field of AI development firmly back in proven systems engineering principles.
It really does.
Yeah.
Before we sign off, I want to pivot slightly. We spent this entire time dissecting the mechanical engineering of how to build these highly structured, artifact-exchanging, multi-agent pipelines. But you always manage to connect the technical architecture to the broader human impact. What is your final thought for the listener to mull over as they digest all of this?
I want you to think about what this architectural blueprint means for the future of the human worker. The post explicitly states that human review must be engineered as a first-class role for policy judgment and final review. As these AI pipelines become more capable of executing the intermediate steps of work, the drafting, the coding, the data extraction, our main job is shifting. We are moving away from being the primary generators of raw information and moving toward being the ultimate arbiters of truth and policy over agent-generated artifacts. How does that shift the specific cognitive skills we need to cultivate today? Are we transitioning entirely from a world of creators to a world of editors, judges, and workflow architects? And if that is true, how do we train the next generation to have the deep critical thinking required to accurately judge the output of an automated debate if they never had to grind through generating the raw work themselves?
That is a staggering shift in how we need to think about our own value and our own training in the workplace. It's no longer about competing with the agents to produce faster. It's about governing them,
structuring them, and evaluating their artifacts with uncompromising rigor. Thank you for joining us on this deep dive into the rooted layers research. We love tearing into these complex architectural topics and finding the grounded, practical insights you can actually apply to your work. Keep questioning the hype, keep demanding clear metrics, and keep learning. Farewell.